Okay, you should have read in the book all these words and definitions, and written your own definitions, and drew your own diagrams. So I'm not going to redefine everything. If you have a question about your definitions, please ask. But I am going to quickly draw a diagram of the definition, and then maybe if you messed up on your diagram, or it might help you clarify something. But my guess is that you've already read the definition and you're okay. So a circle, the diagram, looks something like this. And obviously I just drew this dot right here, so that is the center of the circle, which is our second vocabulary word. Then we have a radius of the circle, right? So the red part is the radius, which establishes the definition of a circle. Think about that. A chord, so here this purple part is a chord. So notice, what is a chord? What does it do? Then if we go down our vocabulary words, we have a secant. This is a secant. Oh, I used the same color. Oh well. This is a secant. How about a diameter? A diameter is a special type of chord, right? It's a chord that goes through the center. Oops, I said I wasn't going to define. But this orange one is a diameter. And obviously you should have had a separate picture for each one of these definitions. I'm combining them all in one picture. We have a tangent. So a tangent looks something like this, except that's not very good. It should only intersect at one point on the outside edge of the circle, so this is called a tangent. And then finally we have a sphere. So a sphere is a little bit trickier, right? That's going to be a three-dimensional object. So that's the best I can do with a sphere. So it's going into the board, and this is the sphere, something like that. Okay, let's look at our second page of definitions. So you have congruent circles or congruent spheres. I'm only going to draw the circles because spheres are a little bit harder to draw, and it's particularly to make congruent. So congruent circles look like this. I think the way, how could you identify that they're congruent to each other? Probably the easiest way is to do this. So what did I do? I made the radiuses equal in length. I'm showing you that the radiuses are congruent. They have the same measure, therefore these circles must be congruent. Concentric circles. What are concentric circles? So a concentric circle, they share the same center, right? Think of like a bullseye. A dartboard with a bullseye. Concentric spheres, again, going to be a little bit more difficult to draw. Inscribed circle or polygon. So what does an inscribed circle or polygon look like? Two different pictures. An inscribed circle is when you have a circle on the inside of a polygon. Ooh. Oh, that's not good at all. I hope you were able to do a little bit better than I was. So maybe it's easier, whoopsie, to start with the polygon. If I inscribe a circle in there, the circle should touch all four sides just at one spot, which means it should pretty much be a square. But if I inscribe a polygon in a circle, so let's say I put the circle here and I inscribe the polygon, then I can make the polygon however big I want to, however many sides I want to, and that's an inscribed polygon. So this is an inscribed polygon, and this one is the inscribed circle. And then we have circumscribed circle or circumscribed polygon. So a circumscribed circle is when the circle is on the outside. So a circumscribed circle is when you have an inscribed polygon. A circumscribed polygon is when the polygon is on the outside. So this is an example of a circumscribed polygon. Okay, so now that you learned all these definitions, you should be able to identify some of the different pieces and diagrams. So before we continue, I want you to go ahead and pause this video and try to fill in these blanks on your own. Or perhaps you've already filled in the blanks because you did it in advance and you're just checking your answers, in which case don't pause and just check your answers. Okay, so hopefully you identified these different vocabulary words, so check them. OM is a radius, segment OM. Segment MN is a chord. Notice because of the notation here, segment. And notice these notations going back to chapter 1. Some of these haunted you back then. I hope you have mastered them and you know what these segments or these notations represent. A secant is a line. Hopefully you have that in your definition. So the difference between a chord and a secant. Secant goes on forever and ever. A chord just intersects the outside circumference from one side of a circle to the other. Diameter, specific type of chord that goes to the center. Tangent segment. This is a tangent segment because it has a segment symbol above the two letters. But ML is a line, so therefore that's a tangent. Point M, that's a point of tangency. That's where the tangent meets the circle on the outside edge. Down here with the three-dimensional sphere, line TU. Notice my notation. Line TU is the tangent. A secant would be line PQ and a chord would be segment PQ. Assuming that these points are on the outside surface of the sphere, going something like this. Like we're assuming that that's a sphere going into the wall, these points are on the outside edge. And name two radii, well here is a radius US, and then if R was on the outside edge, then RS could also be a radius. So could SP if P was on the outside edge, or SQ. So there are multiple ones. Okay, moving on. You should do these activities on your own and see what you get. So go ahead and pause if you haven't done this yet. Pause, do the activity, and then try to fill in the theorem, and then start it when you're done and see if you got it right. Okay, if you did the activity, you would have tried your best to draw a tangent, so a place where it intersects a circle at one point, a tangent on a different circle just to do it more than one time. Then you had to draw a radius from the center out to the point of tangency, from the center out to the point of tangency. And had you measured that with a protractor, it should have been really close to 90 degrees. So therefore, filling in the theorem below, if a line is tangent to a circle, then the line is perpendicular to the radius drawn to the point of tangency. So when you have a radius intersect a tangent, they always intersect each other at 90 degrees. They are perpendicular to each other. Moving on, continuing with the activity, you need to continue with 4 and 5. Try this next box to fill it in, and then see if you can fill in Theorem 2, 9.2. When you're finished, unpause and check your work with me. Okay, so hopefully you finished this second part. Number 4, it said to draw a line. Oops, I don't know what happened here to my word. To draw a line outside, another tangent, sorry, not a line, but another tangent to a circle, and have it intersect to a point not on the circle, which is outside of the circle, here point B. And if I name this point of intersection A and this point of intersection C, where the tangent meets the circle, and you should have measured these distances, and you should have learned that they are really close to each other. So they are congruent to each other or equal in measure. So filling this in, tangents to a circle from a point not on the circle are congruent. And therefore, putting those two things together, if a line in the plane of a circle, so this line, blue line right here is in the plane of a circle, is perpendicular to a radius at its outer end point, then the line is tangent to the circle. So there you have it, the relationship between tangents and radiuses, radii, and how they intersect at 90 degrees. Now we have what is a common tangent. Open your book to page 334 and define common tangent, then draw and define the difference between an internal tangent and an external tangent. So go ahead and do that on your own. You should be able to read about it, and then do the same thing down here. Try to draw pictures to help you differentiate. If you don't understand, you can always ask your peers for more information, or you can ask me. But see if you can do it on your own first and draw some diagrams. Considering you were looking in the textbook to get these definitions and pictures, I'm sure you didn't have any problems, but common internal tangent, notice why do you think it's called an internal tangent? Because it's shared and it's on the inside. If you consider the outside, if you were to connect the outside edges here, like this, oops, to go across, right? So that would be the outside edge, therefore this is the inside. So internal tangent, and then an external tangent would just be something that connected the outside edges to each other. And finally down here, internally tangent circles, that means the circles one inside the other and they share a tangent. And then externally tangent circles, they're side by side, sharing a point in common on the outside of their circumference. And that's it for 9.1 and 9.2. So do your work the rest of the class, and feel free to ask me questions whenever you have them.